And welcome to Mission Control. I'm Kelly Humphries, and with me is Jeff Sweterlitsch, who
Hello.
is the principal investigator for the Amine Swingbed experiment. Jeff, welcome to Mission Control.
Thank you.
So this is an interesting experiment. It has a funny sounding name, I got to
hmm
admit. Tell us a little bit about what Amine Swingbed is all about.
Okay. Amine Swingbed is an experiment where we are testing out a new technology that is going to be developed for the Orion program. It is intended to remove carbon dioxide and humidity from the cabin environment in one complete package. And so what we're doing now is we're testing it out in a relevant spacecraft environment on orbit, real humans, real crew members, and seeing how it interfaces with all the other systems that are going on. One of the most important things of a technology is how does it work with other systems?
Okay, and for those who are not familiar,
Sure,
Orion is the next spacecraft that NASA is developing along with the Space Launch System that'll be able to take us farther out into the universe than we've gone before,
that is
hopefully
correct.
to asteroids and Mars.
Correct. And so this is a small, compact system that does the water and humidity job all at the same time.
Okay, and how big is it? You say small and compact.
Well, the system itself weighs about 40 kilograms and is about 18 inches tall, 16 inches wide, 14 inches deep. It's low power, it doesn't require any source of heat, and so you just need a blower to be able to move air through the swing bed. And then that when a sorbent bed loads up with carbon dioxide, it then vents that carbon dioxide out to space vacuum. So it's a regenerable process. We can use this over and over and over as long as I have a blower and an access to space vacuum.
Okay, now I understand that you are actually using the
Yes.
experiment. You're removing carbon dioxide
hmm
from the atmosphere. When did it launch, and how was the activation process?
Okay. We launched actually the hardware in two parts because of logistics. We flew the heart of the system, the swing bed itself, back in probably 3 years ago. And then 2 years ago, we launched on the last shuttle flight the remaining hardware, the blowers, the heaters, the controllers. And so for the last 16 months, we've been integrating it, putting it together. We've had a number of troubleshooting challenges. The main issue is we never tested these on the ground. So the first time they were ever put together was on orbit. Everyone was holding their breath to see how this would turn out.
Kind of like the space station itself.
Yes, yes, exactly. And so we had a number of setbacks. We got over all those setbacks, working with a great team on the ground and a really fantastic crew that helped us out a lot. And so the next step that we did was we started operating it in early May.
And how much carbon dioxide are you removing?
By our calculations, we're removing about a pound to a pound and a half a day uh, during our 8-hour run that we do, and that's equivalent to about a crew member and a half or so.
Okay, and so for Orion, that's about a quarter of the load you got to carry.
Right, and what's more important is the space station had different requirements than Orion. We're trying to minimize the amount of water vapor that we vent out as well as air. In Orion, you do it all at once. Station had different requirements, so we had to operate the swing bed differently. So
And
we
those
can
requirements are that you want to recover all that water because
on
we
station,
have a
yes,
water recycling system and we use that to minimize resupply.
correct. If I was using this on Orion, I could dump almost 15 pounds a day of water overboard, and we just don't want to do that with station.
Okay, and so since you started it going, it's running smoothly?
It's been running smoothly. We've had no issues. We actually can see carbon dioxide on our system dropping with time. So that shows that, yes, we are really scrubbing carbon dioxide. It's not just a funny with our sensors. Everything's looking good.
Okay. And obviously, this is really important to the future human exploration outside of the Earth Moon system
hmm
because when you go farther, you've got to have low power systems that do this kind of job. Everybody remembers Apollo 13,
Right.
and one of the big issues they had was scrubbing the carbon dioxide after the accident.
hmm
After the accident, they had to make a special kludge to put the right filter.
Correct.
So tell us a little bit about what the value of this is going to be for the future human exploration.
The value for this is it's small, compact, and as we're running it on the station, we minimize our water losses. So you need another system that will actually turn the water vapor into water liquid, which is then further processed by other hardware. But because it doesn't require a lot of power, there's an advantage there that for longer missions, you are ultimately using less power, whether they're batteries, solar, what have you.
Okay. And does this have application to things in space exploration other than just the spaceships? Does it have
There is,
application for habitats?
well, there's actually a smaller version of this that's being tested for new suits. So sort of a personalized size of this swing bed. And for other habitats, again, it depends upon how you want to operate. If saving carbon dioxide is important, there are other things you need to do. We're not saving carbon dioxide with our experiment, and for short to medium duration missions, it's not really necessary to try to save it. On station, long-term mission, you want to save carbon dioxide as well. So other hardware that's on station is doing that job.
Okay. Well, Jeff, we'd like to learn about the people that work behind the scenes on the space station. Tell
Okay.
us a little bit about yourself. Where are you from? Where'd you go to school? How long have you been here?
Okay. I grew up in Vermont and then found myself at the University of Pennsylvania, where I got my bachelor's in chemical engineering, and then went out to Iowa State and got my PhD in chemical engineering, and I was focusing a lot on renewable energy. I knew somebody who knew somebody who knew somebody, and I came to NASA a little over 8 years ago. And so I've been in the Crew and Thermal Systems division ever since.
Great. So would you call this a green technology?
I'd call it probably a low energy technology. Certainly having regenerable is good. You don't have to keep throwing stuff away like you do with the old system that's used lithium hydroxide. That was a one-time use and that's it. Now you can use the sorbent media over and over and over.
Okay. How long do you plan to do this experiment on the space station?
We have run for about 30 hours. We want to run for 1,000. And so we anticipate it's going to take about 6 to 7 months to complete all those hours. We have to schedule with other payloads. After that, it's really up to the space station program what they want to do with the hardware. There's a piece of equipment up there that can scrub carbon dioxide.
Okay. And then what about Orion? When do you look to integrate that into the Orion systems?
I don't know the specific dates on when they want to start testing it out for either unmanned or manned flights. We've been doing a lot of testing on the ground for the last 7 years, starting to integrate with other portions of the Orion environmental control systems. Really testing how does it interface with humans, other systems, blowers that are specific to an Orion architecture rather than for station architecture. So we've done a lot of ground testing. We obviously haven't flown it yet. This is the first time that we've flown the space swing bed to the station.
Great. Well, Jeff Sweterlitsch with the Amine Swingbed experiment, thank you so much for being with us here in Mission Control today and sharing this interesting technology demonstration on the space station.
It was my pleasure. Thank you.